Hello everyone, welcome to day 9th of January Leetcode challenge, and I hope all of you are having a great time over this weekend. Now let's quickly talk about today's question. Today's question is robot bounded in circle. In this question we are given a robot that is standing at the 0,0 index, that means the origin, and the robot faces towards the north direction. We are also given the set of instructions around which the robot moves. And the instructions are as follows. G signifies that the robot goes straight by 1 unit. Left signifies the robot takes the left turn. Right signifies the robot takes the right turn. We have to perform all the set of instructions that are given to us, and we need to check if the robot forms a circular path and arrives back at the origin or not. If it does, then we need to return true. If it doesn't, then we need to return false. Also, there's an important instruction that is specified that the robot keeps on performing these instructions forever. So whatever instruction set is there given to us, the robot is performing those instructions in an infinite loop kind of a manner. Here are a few examples that are specified. I'll be talking about these examples by the presentation that I have created for this. So let's quickly move on to it. Robot bounded in a circle, Leetcode 1041. It's a medium level question on Leetcode, and the concept that we will use to solve this question is geometry. We are not using any dynamic programming, two pointer, graph iteration. It's not on those lines. It's simple and straightforward geometry. If this question comes up in an interview, the intent of the interviewer is to make sure that you guys are able to write multiple test cases appropriately and drive through the stimulation on how the robot is gonna move around. If you are able to do that, 90% of the algo is solved. So let's walk through multiple test cases on how the robot is actually behaving while moving across instructions. So let's take a very simple case. Let's hypothetically assume that this point happens to be the origin. And in some scenario, the robot moves by some units in the forward direction, then takes a right turn, and then progresses towards the downwards direction by some more units. In the question, it was also specified that robot moves across these instructions in an infinite loop kind of a manner. So as per the first set of instructions, robot has moved in these three directions. Let's consider a case where robot tries to attempt the next set of directions. So what is gonna happen? So robot right now it's standing at this position. So again, it will move in the forward direction by x units. Similarly, the robot moves in the forward direction from here in the x units. Robot then moves towards the right direction. Robot moves towards the right direction. So if you are standing over here, then you can visualize that this direction will be right of this direction. Then again, robot moves towards the bottom direction and takes a right turn again over here, and it moves by y units. So again, robot moves in the right direction over here. If the robot is standing facing north over like this, and it moves towards the bottom direction, in this case it would be the north direction by y units. So what actually happened? The robot finally arrived at the original position, which is nothing but 0,0, that is the origin. That simply signifies that the robot has finally reached the starting position and we have to return true in such case. Let's try and visualize some more cases and let's see whether this hypothesis are actually true for all possible cases or not. So let's take the case where the robot moves in the north direction by x units and then finally takes a right turn. In the question, it was only specified that the robot is moving in the forward direction by a unit method. In the rest of the cases, he was just taking turns. So the length here is actually 0. So robot has just taken a turn and has not moved by any unit. So let's proceed ahead and let's try and create more instances of these set of instructions. Right now the robot is standing at this position and it is facing towards right. And what he's gonna do, he'll move forward by x units in the right direction. So robot moves towards the right direction by x units. Again, it makes a right turn. So let the robot make a right turn. Robot has made the right turn. Let's again progress ahead and perform the same instructions. So robot is gonna move by x units and perform a right turn. Robot has done that and he is now standing at this particular position. Again, robot is going to execute the same set of instructions. He's going to move by x units and take the right turn. So as soon as he finally takes the last right turn, he has arrived at the starting position, which is nothing but origin. Again, we observe that the robot was able to arrive at the origin given these set of instructions. Let's proceed ahead. Let's take another interesting case. So let's hypothetically assume that the instructions that are given to us are on these lines. The robot moves by x units, take a right turn, and then again take a left turn. So first he moves right, and then he moves left, and then finally progresses by y units in the north direction. So these are the initial set of instructions that are given to us. Now let's recursively repeat the set of instructions. So robot is standing over here. What he's gonna do, he'll move toward x units in the north direction, then take a right turn, then take a left turn, and finally move by y units. And what do you see here? The robot is moving far away from the origin, and he's going to continuously progress towards infinity as he moves ahead with the set of instructions. In no possible way the robot is going to come back. So what can we conclude from this? We can simply conclude that if the robot, after executing the initial set of instructions, is facing towards the north direction, then there is no possible way in which he can return to origin. In case he is pointing in any other direction, right, left, or bottom, then he will definitely be able to come at the origin at the initial position from where he started, which is nothing but 0, 0. So this was the hypothesis that the interviewer wanted you to draw by visualizing multiple test cases, and if you are able to do it and communicate properly with the interviewer regarding these simulations, then he'll be more than happy and definitely pass you in the interview. So let's quickly walk through the examples that were specified in the question. In the first case, we are given, let's assume this is the starting position named origin. The robot moves in the forward direction by 1 unit. The robot moves by 1 unit. Then again robot moves by 1 unit. Then he takes a left turn. So robot takes a left turn. Then he's standing at the same position. Then again he takes a left turn. So left would be this. And since these are just change in the direction, the robot is not moving. So robot is actually standing at the same position. He has just changed the direction in which he's going to move. Again he's going to move 2 units in the north direction. So the robot is standing over here and he's going to come back to the same position. And finally robot arrived back at 0, 0. This is a pretty simple case where the robot himself has arrived at origin after executing the first set of instructions. Pretty simple and straightforward. So in such case we will return true. Let's proceed ahead. Next we have GG. The robot is standing over here and robot moves by 2 units in the forward direction, and we are done executing the initial set of instructions. It's gonna infinitely perform the same thing and keep on moving forward in the north direction, as a result of which we are gonna return false, because after initial set of instructions the robot is still facing in the north direction. Let's proceed ahead. Next we have GL. So let's assume the robot is standing over here and robot moves by 1 unit in the north direction, then takes a left turn. Since he has taken the left turn, now he is pointing towards somewhere in the left, and we can say that robot is definitely gonna come back as per this hypothesis that we just talked about. Now let's quickly move on to the coding section. The coding section is pretty simple and straightforward. It's just if and else cases that I have written. So I'll talk about more in the coding part. So let's quickly look at it. Here I have defined a private enum that has 4 possible options: north, south, east and west, and I have taken 2 variables x and y that signifies the coordinates of the robot. By default those are initialized to origin. I have also taken a default value for direction that signifies to what direction is the robot currently facing. So by default it is facing towards north. And let's start the iteration. I have created a for loop where I am iterating over all set of instructions. If my current instructions happens to be G, that means robot is definitely gonna move by 1 unit. We are not sure whether it's gonna be right, left, top or bottom. That depends on the direction in which the robot is right now facing. If it happens to be north, then we'll increment the y pointer. If it happens to be south, then we'll decrement the y coordinate. If it happens to be west, then we'll decrement the x coordinate. If it happens to be east, then we will increment the x coordinate. So this is pretty simple and straightforward. I hope you are able to follow along. And in case my instruction set happens to be left, then what I'm going to do, again a switch case where I'm just changing the direction. If the current direction happens to be north and instruction happens to be left, then the updated direction would be west. Similarly, if current direction happens to be south and the instruction happen to be left, then the updated direction would be east. Similarly, the rest too can be visualized as well. Now, if you go in the else case where the instruction happens to be right, you can think through these cases how the robot is actually behaving depending upon the current direction of the robot. Once we are out of the loop, what we are going to check, either the robot would have reached the origin position by himself after executing the first set of instruction. If it does, then we simply return true in those cases. Otherwise, what we are going to check, if the current direction of the robot happens to be in north, then we have to simply abort the process and say false. It's simply not possible for the robot to reach back to origin if we continuously recursively follow the same set of instructions. And in the end, it simply signifies that the robot is able to arrive at the solution by the hypothesis that we drew in the question. The time complexity of this approach is pretty simple and straightforward. The number of instructions that are given to us, this length of the instruction string, and we are not using any extra space, so the space complexity is also constant time. This brings me to the end of today's session. I hope you enjoyed it. If you did, please don't forget to like, share, and subscribe to the channel. Thanks for viewing it. Have a great day ahead and stay tuned for more updates from Coding Decoded. I'll see you tomorrow with another fresh question. But till then, goodbye.